see if that works, but it's pretty hard.
Same time as I watch you.
Secret class president.
I forget all the stuff. Nice.
He's very nice. I kind of believe it.
On which Fordham account?
No.
I think every time the three of us meet, he just attributes to you because you're by far the loudest.
Okay.
I'm not saying it.
Now let's take a look at this.
Oh, God.
This is a simple input-output table
Simple?
in which we divide the economy into three sectors: agriculture, industry, and services. This is from, this is two, right? Now, XAA represents the amount of agriculture that will go back into agriculture. XAI is the amount of agriculture that will end in industry. XAS, the amount of agriculture and services. And then when we add these three up, we get the inter-industry demand for agriculture.
Is that it?
Now, YA is the amount of agriculture that goes back to households. Okay?
How do we find that?
GDP can be accounted for in two ways. Y can be equal to C plus G plus I plus X minus N. One way you can account for GDP. This is by expenditure. And it can also be equal to income, agriculture plus GDP in industry plus GDP in services. Now you can break these down further. This is called by reducing sectors. This producing sector part is called the supply side of the economy. By expenditure is the demand side of the economy. Right? These two have to equal. Supply of GDP has to equal demand of YS. So this is what we're looking at here. YA, YI. That's GDP. When you add those up, you get GDP, total GDP. Now, when you add this final demand to the industry demand, you get the total output of GDP, PA. Now, likewise, with industry. XIA is the amount of industry that goes into agriculture. There can be tractors and things like that. Say it should be XI here. This is XII here. That'll be the amount of industry that goes into industry. And XIS is the amount of industry that goes into here should be X.
So this is XSI.
This is the XIS. Doesn't show up here. Well done. I just don't see it well up here. It's blurry.
It's pretty blurry.
And when you add these up, you get the amount of final demand that goes to industry. When you add the final demand to industry demand, you get the total amount of industry demand. And likewise, services. Services in agriculture are like farm banks, things like that. The services in industry, it could be like accounting services. And the services is service sector and many services. So you add this up, you get the final demand, and then you get total output. Now, if you take these numbers, TA, TI, TS, and move them over here, the bottom of this, okay, the difference between this sum and this number is this value added. You add up these three numbers, and subtract it from that number, you'll get this value added. You add up these three numbers, and subtract it from that number, you get the value added. When you add up the value added in industry plus the value added in agriculture, plus the value added in industry, plus the value added in services, you'll get GDP. So another way of looking at GDP is through the value added. Value added agriculture plus the value added in industry plus the value added. All these three values of GDP are the same. You can also get GDP by income, yeah.
Will the total output on the right be the same as the one on the bottom?
Yeah, they're exactly the same numbers.
Okay, so you add in final demand to those total outputs at the bottom too.
No. You get this number here, you add up these three, and subtract it from this, and you get the value added. But when you add these three, you'll get exactly the sum of these. All right? This is pure economic theory. It's something you don't normally learn unless you study input-output. But it's got to do that. This has got to do that. When the government puts together the accounts, that's the way they got to add up. So the sum of the value added is equal to the sum of the final demand. And that's GDP. Now, we talk about these technological coefficients. A11 is XAA divided by TA. So let's take a look again. If you take XAA and divide it by TA, you get A11. Take this and divide it by TA, you get X21. And this divided by that, you get X31. And so on for each of these columns.
I missed that.
So we call these the technological coefficients. A11, A21, A12, A12, A12.
Like if you divide XA by.
Where is this?
Oh, I hope he gives us
That's a matrix.
Yeah,
Remember we're talking about matrix. That's a matrix.
Are we gonna be able to get a copy of this?
Yeah.
Okay, cool.
If you'd like a copy,
I would love a copy of this,
email it.
because I'm trying to,
Yeah.
I'm trying to type it, but I'm not getting it.
Yeah. Good idea.
Thank you.
And then we get the total output, we can put this vector, TA, TI, TA.
Oh, okay.
And final demand, we can put in this vector, GDP. So what we get then, if we take this vector, multiply it by this, t times t sub 0, you'll get a string of equations, three unknowns, okay, which represent these numbers up here. And if you add those to these,
Oh, that's what that
to the final demand, we get the total output. So this is a matrix equation. Tx, t times t sub 0. This is the time sign. T times t sub 0. Okay. The t times t sub 0, that's the inter-industry demand. Plus y, which is the final demand, will give you the total output.
is. Okay.
Now, when you solve this for y, you have to bring this on the other side, so it becomes minus t times d sub 0. But in order to subtract these two matrices, they have to be the same dimension. So we have to introduce the identity matrix, put them in the same dimension. Then if we factor the t0 on the right side, we get this, and from that we get this. Now I'm going to download this, and then you guys can email. You can email them to yourself.
We connect to his computer. I can't remember. It's in his computer. Does it say up there? What's his computer?
Input output structure. We'll get a stage of the document.
What's your computer name then?
So let's see if it's there. There it is. Right? So, who would like to email it to the class? How about you, Mom?
You know how to do that. Yeah, but you can't email me because you always forget my name.
Oh, it's just like that, everybody.
Except for me. For some strange reason, I'm not on that list. So I'm just going to go up there and email it to myself. But what's that computer name on that? You can email it to me?
Huh?
I don't have it. I don't have it yet. I don't know why you had a problem.
You got a problem, he'll stop and check it out.
Oh. Why is it just... What? Okay, I don't have a pen. Can I borrow your pen? Yeah. You're very wrong. Why do you need my name? See, I'm not up there. Look at that. Oh wait, I am up there. Why do I never get anything from you?
Maybe you should check your email.
I do, you dick. Look at that, I have data.
I know you want to pay attention to the instructions.
I don't know what it is, the ID number. What's I don't know my ID number. Who knows their ID number?
Am I supposed to be number 3 because Mike took up most of line 2?
Yes, you're number 3. Hey, that's weird. Well, just put your name in the address. Weird. Oh,
Oop.
$160,000. That's fucking great. I can't live in this state anymore. This state sucks. Maybe it's just on that one.
Yeah, it didn't go through.
All right. Well, that's all done. So you all have the basic copy, right?
What's up?
Didn't get it yet. I don't know. I got you. Don't make me nervous.
No, I don't have it. Oh, there we go.
You have my email, so if I don't have it, you can send it to me.
No, send it to you right now.
Cool. I'll get like 9 copies done. Yeah, no, I don't have it. What is wrong with it? It's like 4 email.
Now, I'm going to put this back.
Yep. Gmail?
Yeah, Gmail, yeah. Whatever I've been emailing you to past, like, Mondays. There you go.
You got it?
Received it.
Delivery confirmation.
Oh, this looks dope. Thanks. That you said. Yeah. Send it to me. You're gonna know go outside and kick rocks.
Hey, does yours end with TO equals and then nothing?
What the heck is this?
Hold on, did you check there's another page?
I only got one page.
Dude, there are 2 pages. TO equals bracket TATITS.
That's it.
Weird. So that's how you get it. So by adding the identity matrix, it's 1 minus a.
Oh,
I get it. I don't get why I'm doing it, but I get it. I can do it.
You can do it.
You can do it. Oh,
Go ahead.
oh. It's been a while. Oh.
Now, this is an example of the problem.
yeah.
Right?
Can you send that to us, too?
Now, this is the flow matrix up here. So, the total agricultural output is over this thing. And this is how much goes into final demand. And this is how much goes into, when you add this plus this, you get that number. Right? But this number is broken down by these 3. So the amount of agriculture goes in agriculture is 42,367. The amount that goes to industry and the amount that goes to services. You add up these 3 numbers and you get that. You take this number and you add it to this number and you get that. All right? And it's the same for industry and services. Now, when you get these numbers, you take these numbers, put them over here, and see they're exactly the same number. Right? Total output. We add up these 3 numbers, subtract from this, and we get that number. And you can see that over here. It's B6 minus B2 minus B3.
You didn't send it. Or the other one, yeah.
So that's how you get the value added.
Okay.
Well, I opened that one, yeah.
Like B6 total input minus, okay.
Same here. Same here. Now, when you add these 3 values added, you get the same number over here. You get this number here, which is the same as adding up these. Now, here we're making the technical coefficient, which is the T meter.
Keep going.
So you can see that the first number here, B2, which is this number right here, divided by 37,609.
Okay.
Where's it? Did you guys get this?
Wait, so it's just, it
This
should,
number down here, B3, divided by 37,609.
okay.
So that gives you the technological coefficient, the T meter. This is the identity matrix. Now, this is the identity minus the technological. So it takes this identity matrix, and subtract from it this matrix.
Oh.
So, for example, that number
Now I get it.
is B15,
Which is agriculture technical coefficient.
B15 is here, minus this number over here. Right?
That's cool.
That's all.
So the technical coefficients minus the identity matrix is the,
That's identity matrix.
No, it's the
minus
identity
technical
matrix
coefficient.
minus the technological coefficient.
That's why they're negative number.
Identity minus technological. They're both 3 by 3.
equals,
Let me just show you again. 1, 2, 3, 4, 5, 6. So this number would be that number, take away that number.
like, on the identity here, just follow suit with the
Oh,
technical.
that makes sense.
Like, whenever you get this,
This is going to be equal to.
so you just subtract this number from that number.
I see.
This number from that number.
Yeah.
And then what's the result?
Is, you see underneath this says identity minus technical?
Yeah.
That's the result.
Oh, okay.
We have this. I mean,
Let me show you how we get it. Let me show you how we get it.
Do you think that is too much to ask?
That's gonna be equal to the identity
Watch, just watch.
Divide each number.
minus
Specified.
that number.
Okay.
Then you get this 0.88. You get the next number, it's gonna be equal to the identity 0
What's the identity?
minus
matrix is because you have
that.
I don't understand.
In order to get the inverse.
It just there because it has to be that.
So that's the way you produce the identity minus the technology.
So you have one.
So that's what
What is the identity? Like, what is that?
Yes, when you take the identity and you multiply it by any number, any matrix, you'll get back the same. Someone else?
What? If you take the identity and you multiply it by any matrix, you get back the same
We did
matrix.
that last week.
Yeah, I was sick.
And the technical is given, or do we have no?
You have to compute this.
That was what you get.
You have to compute that. Now, the instruction sheet that you just got emailed gives you the outline. So you put that against this. Yeah.
Can you please click one of the cells in the technical coefficients matrix?
See the equation.
So the 376.
It's agriculture divided by total output.
Okay.
So
What is it?
it's agriculture divided by total input and industry divided by total input.
Right.
It's just whatever's in D. Like the
Whatever the
total-
bottom line.
Yeah.
Got it?
Yeah.
Good. It's all on that sheet that you emailed, if you read it carefully.
What's TA?
Oh, that's total.
So this is the identity minus the
Oh,
technology.
okay.
Now, the next thing you gotta do is get the inverse of this, the inverse of this, the 5 minus 100, okay? So you gotta take this and get the inverse, that's this over here. Let me show you how you do that. You put equal, n inverse,
Oh, cool.
open parentheses, and then you take this thing, like that, close it, you have Control, Shift, Enter. And there it is.
It's just awesome.
That gives you the inverse. That's sweet.
It is very sweet.
These numbers are exactly the same as these.
The actual math is just. Am I crazy?
So you have that software.
So it's
Now,
all
believe me,
divided by one.
this is a miracle from my point of view. It's like, I learned this in the Dark Ages. We had to do it by hand. But the idea that you can just do this like this in seconds. So with last Monday night, after we met, I went out with a friend of mine from the UN, an Egyptian.
Hmm?
His name is Gamal Elish. And he worked for the Egyptian Ministry of Economics under Sadat. He's an older guy now. He built the first input-output table for Egypt. It was an 89 by 89 table. It was very big for the time. And then they wanted to do this inverse. They told me to do the inverse. The only place you could have it done was in Paris. So they had to send the whole matrix to Paris to have it done. And they did it in a week. And then they sent it back. And he was absolutely thrilled to be able to get it done in a week. Because they were trying to do it by hand in Cairo. Can you imagine? 89 by 89 feet, inverted by hand. Almost impossible. It took Richard von Neumann months to invert one to build the atom bomb. So he was tickled that they had, and they used a big computer in Paris. They didn't use a microcomputer. They didn't exist. Big mainframe to do it. But it came back perfect. They had no errors. And they were able to solve the system for the Egyptian economy. Now recently, he was back in Egypt this summer, and he was visiting some people, and he was visiting his nephew, who also now was doing the same kind of job that he did when he was in Egypt. And he was smiling. He said, "Uncle, if I want to do that now, I can want to be EC. It takes me seconds. I do that in seconds now." But you can't appreciate this unless you're old enough to have gone through it the hard way. How miraculous. Now, why are we doing all this? Right? This is what we see next. Once we get that inverse, we multiply it by the final demand components, and it tells us how much we have to produce in each sector in order to get that final demand. Now suppose they have it in plan. Egypt under Saddam was a socialist state, and they were trying to follow the Soviet model of planning. The Soviet model of planning was this. This is what they did in the Soviet Union. Suppose they wanted to say grow at 3%.
Grow.
They wanted the final demand components to change at a certain rate. It would change the final demand components, redo the system, and they'll get the new total output. For example, if we take this number here, and divide it by that number here, that's an increase of 1%. So this is an increase of 1% in agriculture. Now if we take this number and divide it by that number, that's an increase of 2% in industry. The last one is this number divided by that number. That's an increase of 1.26. So if we're here and we want to go to here, we want to know how much total output we need. And that's what this tells us. To get these numbers, all we do is a matrix multiplication. It equals m multiply, open parentheses, that, comma, that. Control shift enter. And that, these numbers right here. That is the way they did economic planning under socialism. Doesn't mean you can't do it under capitalism. The Japanese used exactly the same method to plan their economy in the 60s. The Japanese did it better than the Soviets did. They were much more honest about what they had in the system.
Of course, because the Russians were a very close economy, that's why it didn't work.
Well, there's a lot of problems. First of all, the Russians didn't know what they had there. Biggest problem. They didn't know what they had there.
So where the FDY and TL up there, where do those come from again? So it's total output and then,
The total, the FDY C+1 is the next year up. Right?
okay.
And that's specified by the model. Let's suppose they say, okay, we expect agriculture to grow by, the final demand for agriculture to go by 1.1%. And final demand for industry to go by 1.02%. And final demand for service to go by 1.026. They do a forecasting model to forecast that. Now, knowing that, and knowing what our technological coefficients are, what do we have to produce as total output?